Okay students, so now I will describe to you how we measure capacitance in this setup. So now what you are saying is the barium titanate capacitor has been inserted into this sample holder and has been put inside the oven. Okay, and this is your frequency controller and power supply and everything. So we have turned this on and it is connected to your sample holder. Okay, only thing that is we have not initiated in this part of the experiment is the oven and the controller for the oven or the temperature sensor. So this is off because this is not needed for this part. In this part we are only measuring the capacitance. So we have to you can look at your manual for the settings bridge, the formulas and all how so it's basically an adaptation of your Wheatstone bridge and it is used for measurement of capacitances. So one of the arms in the bridge will have this capacitor, this unknown capacitor that you are trying to measure. All these capacitors will also have an internal resistance because there are electrodes, there are connections. So for example, there is a contact using these two probes with the capacitor, right? So that contact will itself create a resistance. So there is a series resistance as well as the capacitor. So both these two unknown quantities you can measure using the settings bridge which is inbuilt in this setup. So what you are controlling is controlling the frequency of the input, the overall input signal, and then you have this controller which controls one of the capacitances in basically the opposite arm. Okay, there are four arms. So one of the arm is this unknown capacitor and the resistor, another arm has this capacitor and this resistor, both are variable and you can control their values from here, and the third and the fourth arm has a resistor and a capacitor which are fixed values, which are inside this one. You cannot change it, they have a fixed value. Okay, so that gives us a particular formula, so you can check in manual which will have that formula. So now you see we can vary the frequency, we can also vary the resistance to basically minimize the signal in the CRO. Where is the CRO connected? So you have the settings bridge which has this four arms. In between the arms you have the CRO. Okay, and on the other two terminals of that arm you have the power supply, which is actual power supply which is coming from the external software, and you are modulating the frequency here. So when the bridge is balanced, what happens is that CRO will register the minimum voltage signal, will register the minimum in the amplitude value. Okay, so now you see I can change here the frequency as well as the resistance. So now the resistance, without going into too much details, let's say I can use these knobs and change the resistance and use this knob to change the frequency. So let's say I fix the frequency. I want to find out where the signal becomes minimum by changing the resistance. So let's say I have something like this in my CRO. So this is not obviously not a minimum, right? You can see from here the signal is quite strong, and it will also, you can measure from the scales, divisions, number of divisions you can change from here, and you can measure, because this is a digital oscilloscope, it will actually display the voltage as well, peak to peak value. We can measure it from here. It's actually 35 millivolts. Okay, the peak to peak here. So this is not the minimum, so you can change the frequency or you can change the resistor. Let's say I change the resistor and see how the signal changes. So let's say I'm moving in one direction, you see it is decreasing. Basically I'm actually increasing the resistance. So it's decreasing, keeps decreasing. I'm increasing the resistance. Now you see, after some time what will happen is that it will start increasing as I keep on decreasing. Now you see it has started increasing. So that means the point where it reached the minimum value is my point where the bridge got balanced. So I will go back to that point, and so this is sort of the minimum value that I can attain. So this is where the bridge is balanced. Alright, so the minimum value is like 9-10 millivolts, something like that. Okay, so now I will record whatever is the capacitance from here, whatever is the resistance from here, from the potentiometer that is there. So you have to read the value from there, and you can use the formulas that is given in your manual to calculate the unknown capacitance and the unknown resistance from here. Alright, next part will tell you how to use the temperature control and the oven to measure frequency, so basically capacitance at different temperatures. So so this setup is for measuring capacitance. This setup is for controlling the temperature, so that you can measure capacitance at different temperatures. Alright, this you can also control the frequency, so you can also monitor how the capacitance changes with frequency. So that part of the experiment we are not doing in this session because of the associated difficulties with the measurements. So we are only doing the temperature part. So I will just display how to in a moment. I will show you how to do the temperature part as well. So basically when you are doing the temperature part, we'll keep everything fixed, we'll keep it in the minimum position. So as we change, the capacitor changes a little bit, we'll change the resistor and the if needed the frequency a little bit, and we will get the minimum value, and we will note down the corresponding values of capacitance and resistances for each value of temperature, and then calculate again capacitance from each value of temperature. Okay, alright. So next I will show you how to do the temperature part. Thank you.